25.5 milliamps worth of charge, this thing's good to go. I really like that. No one does it like that. That's so cool. Hey folks, how's it going? Welcome back to the show. For those of you that are new, my name is Luke, and today we're going to be going over all of the different test functions on your 7-function digital multimeter. Most commonly found at Harbor Freight, but when I went to go get it, they were all sold out. And I had to buy it off of Amazon. It is an extremely cheap meter. I think it retails for like maybe $8 at the store. I got it online for like $12. So my expectations are going to be really low for this meter right out of the box. Just when I was tinkering with it, I do hear something wiggling around in there. That's not good. The capacitance function I wasn't really able to get going. And then as always, for those of you that have seen the show before, the NPN and PNP transistor tester port, this style, really any kind of transistor port that's built into a multimeter, I've never seen work accurately. But we'll go through and I'll show you how to use all the different settings. So hopefully it can help you out with your little project. Grab a snack, have a seat, and let's get into it. Okay, I took a look at the manual, which I hate doing. I like to go into these videos just completely cold. There is no advertised capacitance testing setting, even though one might think that based off of this capacitance test setting like you would have on any other meter that's rated for testing capacitance. And another thing along with this is the battery testing function of this is very different from any other meter that I've ever seen on the market. So I thought that was interesting, but I'm glad I took a peek before we got started. We're gonna start at the AC volt. I will say I like this display. I don't normally like the liquid crystal displays. I think they're really outdated, but this one comes off really strong, which is good because it doesn't have a backlight. It's not gonna have a lot of features because it's a very cheap meter, but I think for the price, there's a lot of features for the price. So I don't know, I think it's aged well. HV trying to indicate potentially high voltage that you're measuring, in a relative sense. And then this is a manual ranging multimeter. So something that we want to think about that could be really confusing if you're not used to a manual ranging meter is we have AC volts, and they're saying that's what this test section's for. You have two different numbers. You have 250 and 200. And what they're trying to say is for this setting, you can measure up to 250 volts. And for this one, you can measure up to 200 volts AC, okay? And why would you have multiple selections? That doesn't really seem like a big difference in voltage. Why do they have the two different settings? With a manually selecting meter, the way that I like to approach it is like when we're taking a measurement, voltage or current, think of it like a microscope. And when we start with a big number, we kind of got the microscope lens all the way back here. And see how it's kind of fuzzy down here? We can still see that there's stuff going on, but not very clearly. And as we bring the microscope into focus, now we get a much more detailed picture. That's the way that I like to think about the settings on a manually selecting meter. Is we can start at 250, and even if we're measuring 24 volts AC, you're still going to be able to see it on the 250 setting. But as you bring that resolution to the 200, you're going to start to get a clearer picture, and that will be evident here in just a second. We'll see. I don't know if these leads, I think they're long enough to reach into an outlet like this. I do not personally like to take a measurement of an outlet with test leads, just jamming them in there, but let's see what we get. Okay, so on the 250 volt AC setting, we're seeing a voltage of 118 right out the socket. Now, if I refine my measurement and move to the 200, then I should be able to read this to the tenths, giving me a more accurate, picture of what the actual voltage is there. So let's take a look. And there we go. It's not just floating from 118 to 119. Now it's saying, okay, it's 118 0.5 to 8 volts AC. Okay, so that's kind of how that works. All right, next we've got the 1.5 and 9 volt battery test setting. If you're familiar with other meters and their battery test setting, it's usually going to like basically put a small load on it and it's going to display the voltage or the voltage drop. Here, what it's going to display is, I believe, the milliamps of the battery and what's remaining. And this is the one, I do like this. They're trying to tell you how much charge is available. Okay, so it's going to place a load of 370 milliwatts. And for a 9 volt battery, normal current is 25 milliamps. And then for 1.5 is 4 milliamps. Red to positive, black to negative, and we'll see a display in milliamps how much charge is left. So it's saying I got 4.2. So this is like a fully charged, good to go battery. And then I can do the same with this 9 volt. I'm seeing 25.5 milliamps worth of charge. This thing's good to go. I really like that. No one does it like that. That's so cool. Okay, next up, we're gonna do the DC amperage measurements. And you can see there's two sections here. There's this green section. The largest number is this 200 M. Okay, that's for 200 milli. It's the metric system. I know us here in the US, we're awful at it. I'm awful at it, but that's the way all the meters are set up, so we gotta get used to it. So it's 200 milliamps, or think of it as 0.2 amps of DC current. And then we have 20 milliamps, even smaller. And then this funky looking U here is gonna be microamps. And so 2000 micro is equivalent to 2 milli. So see how that pattern, 222, and then this would be 0.2, 200 microamps. And it's going to be the same rule of thumb as before. Think of it like when we start big at 200 milliamps and work our way down, it's like we're starting the microscope all the way up here, and then we're bringing it into focus as we measure up to 200 milliamps, up to 20, up to 2000 microamps. We also want to pay attention to our ports now. We're always going to keep our black lead in the common port, and then our red lead is rated for 500 milliamps, and it is fused. And there's our ratings for DC and AC voltage. And there's our current rating. We'll keep this red lead in this middle port only for this green section for measuring current. And then I have some resistors. They're really good for controlled small loads. For how cheap it is, it's really good at measuring small amounts of current. So if that's what you got it for, then you should be a happy camper, at least from what I've seen for it so far. So the way that I would interpret this measurement is I'm at 12.1 milliamps. Now, I know that 12 is smaller than 20 milliamps, so that means I can comfortably go down to the next setting, and I should be able to read not only to the tenths, but I'll be able to read to the hundredths, bringing my measurement into focus, right? So then I can bring it down, and now we have it to the hundredths, and now I know, okay, it's not 12.1, it's really 12.09, or it's 12.10. You know, I'm getting that extra detail in there. But 12 is obviously bigger than 2 milliamps or 2000 microamps. So if I were to go down to the next setting, I should see a 1 displayed here. And that's telling me that I'm out of limits. No go. I'm not on the right setting. So we'll leave this at 20. Let's move it on down the line. Okay, now we're starting to get really small. This is 1.19 milliamps, and that number is smaller than 2 milliamps or 2000 microamps. So I can move down to the next setting, and I can get a really accurate number. This is telling me that this is 1,183 microamps of DC current that I'm measuring. And that 1,183 is still bigger than that 200. So if I were to flip it there, I'm going to get that 1. And we can see that it's trying to tell me you're out of limits. Let's go to the last one down. Should be a very small number. 121 microamps. And again, 121 is smaller than 200 microamps. So I can go to the next setting down, take a measurement, and now I have to the tenths place here, 119.5 microamps. I don't even have any meters on me in the lab that can measure that small, or that are rated for that small of a current. So that's actually really exciting. That's really fun. Something you'll want to pay attention to, the only time that you're going to switch this red lead over to this port is for this next setting that we're going to do. And that's for the up to 5 amps of current. You'll take your current measurement in series. You'll always take your current measurements in series. And for those of you that are not too familiar with series versus parallel measurements, when we measure something in series with our meter, we're using the meter wires as a jumper cable to complete the circuit. All right, I tried to lay this out as simply as I could for you. So we have a power source to a light bulb, but our circuit is not complete. So we're going to use the meter to complete the circuit, and then that's how we'll be able to measure the current of it. So then we can see displayed on our meter, it says 2.01. That's how much current the light bulb's using for our circuit. Pretty neat, right? That's the only time that you'll leave it on that setting. Let's go over the HFE. That's your transistor testing. I'm not a fan of this style. Maybe there might be some higher end meters that have gotten away with transistor testing ports built in, but not that I'm aware of. What I would really recommend, if you're looking to do more transistor testing and it's something that you're wanting to get into, I would recommend something like this multifunction tester. I should have one in the link below, and you can literally throw one in from across the room. You press a button, and it's going to give you all the information that you need about the transistor right out of the gate. I don't believe that multimeters are really set up to do proper transistor testing and identification. I know it has the port on here. If you're struggling with it, it's not just you. I've had people in the past, when I've talked about these ports, they say, well, if you get it just right, you can get a measurement for it. That's not the way I believe a meter should work. To me, that's kind of like if you typed in a calculator, 4 times 4, and sometimes it said 13 and sometimes it said 18, and you're like, well, it's like kind of in the ballpark and it's getting close. Like, that's not helping anybody. It should work every time and give you the same number every time. That's where we're at with that. We'll move on to diode testing. I'm curious some meters can vary a lot on what they say when you're taking a measurement of the diode. In case you're not clear, it's the little arrow with the line. Let's take a measurement and see what it tells us. Okay, that's great. So that number that we're seeing there, 547, is the voltage drop in millivolts. I know that might be confusing. So pretend that there's a decimal in front of this 5 right here, and that's the whole number value. So think of it as 0.547 volts, or 547 millivolts. Voltage drop is its own whole different subject, but that's what's being displayed there. And then with the diode, we always want to check it in both directions, and we should see that 1 continue to be displayed, telling us that there's no backflow in our diode, and so it's good. For the first measurement, we should expect to see somewhere between 500 and 800 millivolts of voltage drop on a standard diode. And it's within spec, so we're good. Something I always like to see, I doubt that it can. I always like to see if they can light up an LED, and it can. That's cool. Just a little trick for parties. You'll be a huge hit if you show them that. Let's go into resistor testing. Now, with resistors, kind of like our current testing, there's a lot of numbers, can be a little confusing. You know, we can take the mentality of, you know, start big, work your way small. So here we have 2000 k-ohms. That means 2 million ohms of resistance it can measure up to, right? And then we have 20 k-ohms. So that's 200,000, 20,000, 2,000, 200. You can kind of see the pattern in your head with what's going on there. So I always like to start big if I'm taking a resistive measurement, and we can just see what it's trying to tell us. So this is saying, for the setting that we're in, this can be a little confusing because you would think, oh, I have 1,044 ohms of resistance. We have to take the context of the setting that we have in mind. So whatever number you're seeing here, see how there's a K at the end of their number? Put a K at the end of your number. So the way that we can think about reading this is 1044K or 1,044,000 is the way that you could read that. So let's go down to the next number. Think of a K there or 3 invisible zeros. So this isn't saying 98 ohms, it's saying 98,000 ohms, which is a very different value. So you want to pay attention. You want to pay attention to those little letters that they have on there. I used to, when I was first learning in the beginning, I ignored way too many. Every symbol on here has a purpose, right? So we can think of 98K. Now 98K is smaller than 200K. So I know I can bring this down. Well, now I know it's not just 98K, it's 98,300. But that number is still bigger than 20K. So if I go down to 20K, I'll see that 1 telling me I'm out of limits. Let's go to the next one down. I do a lot of these examples just to try to really drive it home for everybody. We're on the 200K setting and we're seeing 10.0. So we're really seeing 10,000 ohms, but we can get more accurate than that. It's really 9,950 ohms. So there was about a 40 to 50 ohm difference once we got clearer. Again, if I go down to the next setting, that number that we just had is way bigger than 2,000. So we're seeing a 1 telling us we're out of limits. Let's go to the next one down. Okay, we saw this is about 1K or 980. So we can move down further. 983-ish. Let's go to the next resistor down. Okay, this one's 328, still bigger than that last 200 setting. And then what's this little guy down here? So it's little. It's like 70 ohms. 68.5. So the manual ranging can be confusing. There are auto ranging meters. They're generally going to be more expensive. You can find some good deals online. I would check out Amazon. I am partial to a brand called K-Wheats. They are an affiliate of mine. They've got some great deals. I mean, if this is all you need, then who cares? You'll get used to it, right? Just some practice. And then last up, we're going to have the volts DC setting. Again, a large range. And they're saying, hey, 250 volts DC, 220, 2000 millivolts, or think of it as just 2 volts DC and then 0.2 volts DC. And we'll just do a couple DC measurements. Let's do this battery. Let's get it to the right setting first. Okay, so we can measure up to 250 volts DC. That's what the meter says it's rated for. I don't know if I would trust these leads that much, but that's on them. Okay, so we're seeing 14 volts. We can work the dial down to get more clarity, because with batteries, especially too, 14 volts and 13.3 volts are two different numbers, especially since it's a 12-volt battery. So we can work this dial down. See, it's going between 13 and 14. Well, what is it? Okay, well, it's 13.1 or 0.2. Bring it down to the 20 setting. And now we can see to our hundreds place, 13.1314 volts. So it's got a good amount of charge. And then if I go to the 2000 millivolts DC, I get a 1 because it's out of range. There you go. Overall, for the price, I'm really impressed with this product. I had very low expectations. I really loved the battery testing setup that they had for it. The display is a knockout of the park. There's no backlight, there's no hold button. It doesn't have a lot, but it also has a lot at the same time. So if you're learning this stuff, I've got a bunch more videos on every different meter you could think of. I've got a bunch of shorts on different electrical concepts. If you're having trouble with different ones or different electrical components, or how to test them, anything from capacitors to alternators, different kind of stuff. So I hope you enjoyed the video. Let me know down in the comment section your comments, questions, or concerns, and I'll check you on the next one.